Hello, Uggies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, and welcome to another episode of Ask Dave. Today we're going to take a look at a battery pack that we had previously reviewed. It developed some sort of an error code, E76. It's not in the manual. There's something, and no idea what to do with it. Resetting it, everything doesn't seem to do anything with it. So we thought, since this right here is the device in question, and you see the error code right here, it's flashing E76. I wrote to Pytes, email to them, and asked them, what does the error code mean? And the response I got was something to do with the battery management system. And I said, could you be more specific, please? And they said, it's something to do with the battery management system. Okay. Well, what we're going to do, unplug this thing. It doesn't work at all. So what we're going to do is we're going to take it apart. Now, I'm going to take mine apart so you don't have to take yours apart. This thing's heavy. This, by the way, is for ground if you want to connect that to your ground. The interesting thing about these hex bolts is that they really do hold absolutely everything together. Unscrewing this. And look at that. It goes all the way through. Now they've got little rubber thingies, doodankies in here. So we're going to have to push that out. So we got the rest of these out, and we'll just quickly take this thing apart. These bolts go all the way through down to the bottom. This top comes off very easily. Now this right here is the power for the light that's in the handle, and this is the power for the little magnetic charger that charges up your phone too. They've got a cover on this for good reason. Okay, now the whole thing does come out the bottom, which you can see here has got a bunch of stuff connected. This is the actual battery pack. And note that they've got individual cells in here. So if we can get some of these wires undone and out of here, this right here, this circuit board is the battery management system. This is the positive and negative, and there's a stronger positive and negative going down here, okay? This, I think, is the charging, and they go up to the front, where, of course, nothing happens when you try to turn it on. This is the battery pack itself going to the battery management system. I've got a plus plus and a minus minus over here. And these things, you'd think they would unplug. What I'm going to want to do is cut these, because I can't get the thing apart, so I'm going to cut one cable at a time. That's a control cable. We're going to cut one at a time. Now we can get the thing over to here and see the battery management system. This is the battery output, and we're going to take the positive. There is some charge in the battery, I'm sure. So I want to be careful not to get in a position where the plus and the minus ever touch. Okay, the plus is disconnected from the main box. We'll get the minus off. Okay, this is the battery pack right here. Now, it is composed of these cells right here, and lots of them. And each one of those is one lithium cell. And then you put them all together in the battery, and the point of the battery management system is to, you see, the charging will come in probably here, and then these are the outputs here. This is negative, this is positive. Now, it looks like the thing's split in half. Let's take a look at some of the things that we have in here. We've got a lot of wires going to each individual cell or row of cells here, okay? And then what happens is there's a microprocessor sort of thing right here, U1. And that is the thing that's running the algorithm. Here's another device that's running the algorithm in here of how to charge these cells. Now, the 101 are little, basically 1 ohm resistors that develop a little bit of voltage across them. These are actually voltage regulators right here. And the reason for this is to give a slight voltage difference between the various cells, which feeds in to the battery management system over here. These are bigger voltage regulators. Okay, and so they'll take a few of the cells together and work them that way. This is not going to come out. This is the top plate for the batteries, and there's another one on the bottom, which we could take out if we took all these little screws out. But I think we've seen enough. If you buy a fairly large lithium-ion battery, it's going to look like this inside. Now, this is made flat to fit into here, but normally you'd get it up a little bit more like that. And it will have a board like this in the top. And this is what keeps the lithium under control. Battery voltage can go either way, okay, charging in here or discharge out through here. Now, this thing will put out over 1,800 watts, but it only says 1466 watt hours. So it'll run your microwave, yeah, but not for a full hour. It'll run it for several minutes. You could use something this size to run your microwave, like if you're out camping or boondocking in your RV, you can get something through there. Now, you can look over here on this side, and you can see where there would be additional cells. Now, the cells go down and touch these metal things. Just out of curiosity, let's see how much voltage is in the battery. And I'm showing 42.77 volts, okay? So this is not a 12-volt battery. It's showing 42 volts in there. These things are in series parallel, okay, to get 42 volts. Why 42 volts? Very simple. It's easier in terms of the electronic stuff that they have up here to have the battery voltage be higher. So this right here is a little fan, little muffin fan. There's several wires going to it so it can go faster or not quite so fast. And then these hold down that. There's a little bit of airspace in here. These are the wires that are the output of the battery. And let's see where they go. Okay, this is now discharged. There's nothing here. And we can take this out. Now, the reason that this has got this shielding on top of it is because this is where we get the high voltage, 110 volts, 120 volts. Okay, now this thing supposedly has Bluetooth. I had to look for the app, and they wanted me to pay for the app, and I'm going, I'm not going to pay for the app. It should come with the power pack. So we'll get these things off of here. This is actually quite light now. This is where the batteries come in. These are paralleled with each other, and there is a fuse, a 40 amp fuse. You know, I think that's soldered to the circuit board, so it's not going to come out. And I'd have to take the whole circuit board out so I can see sideways into it, or we could use a little mirror. I'm not sure if I have anything. Now, notice the heat sinks on these. These heat sinks go to some little transistors here. These are the power transistors that provide the sine wave output. And then this right here, if we look down into here, okay, what we're looking at are more of those transistors. These are normally voltage regulators right here, and they're mounted to that huge thing. Now, it's got to have a buck converter to take the 12 volts down, so we see the great big toroids with the coils on them. Lots of coils, because this is 60 hertz. Okay, now there's a switching that's done in here, the way switching power supplies work. So this has to take whatever the input is, which comes from over here. If it's 120 volt income, it will run through the system here in such a way that it's cut to charging 48 volts, okay? Now, if you want 110 out, this thing has to be a boost converter to get it up to the right range and then do the work necessary to get it to 60 hertz and a nice sine wave output. We have some kind of a little card right here. This has got a big microprocessor on it right there, okay? So that's what's making this magic thing do all its magic. Now there's another fuse right down there, and that's 5 amps at 250 volts, just out of curiosity, since we've managed to trash this thing in the process of taking it apart. I want to check the continuity on that. We got 0.1 ohms between the leads, so if I hold this here, not blown. I'm going to just put that back in there. This is not blown. These connect down to the 12 volts, the output right here. Okay, so you can get pretty direct output there. They've also got a cigarette lighter plug, which you can see the back of right there. And there's a bunch of little switches. These are actually little push button switches that are on the circuit board. Push them in and out. One thing you have to do when you put a little switch on the circuit board is put a debounce device of some kind on the thing, because what happens is if you push it, you think you've pushed it one, and you think the thing came down like that. Well, actually, if you look at it in slow motion, it comes down, go boom, boom, like that. And the circuitry can interpret that as a continuous number of pulses. Big capacitors, all sorts of things. Here's a little daughter board right here, and each of these does something. The main board is, the motherboard is this big one down here that everything plugs into. Now, these are pretty solidly, everything's pretty solidly mounted, as you would expect, because when you get toroids this size and you run 60 hertz through them, they're going to vibrate slightly. That's why these things are coated with shellac or some sort of a lacquer to hold them in place, a varnish or something. These are huge 350 volt capacitors with 1,000 microfarads. That's a millifarad in each of those right there. And notice at the bottom, they're all glued in so as not to vibrate. So you don't get vibration in this thing, because vibration will kill this thing. So you want the thing to work very, very well for you. Here's something that I think I should point out to you. It's a Pytes product. Now, in China, there's not a strong attachment between a brand and its products, you know, like Baofeng or so on. Some other manufacturers will slap their label on it and sell it. So you've got kind of a manufacturing and then a marketing thing that are separated from each other a little bit. In some ways, it's like if you're a Ford dealer, you sell Fords. Well, Ford parts are sourced from all over the world, including a lot in Canada and Mexico, which is what the North American Free Trade Agreement was originally about, but times change. Okay, so what we've seen, and I really want to point this out on this, this is very solidly built, okay? We think Chinese manufacturer, kind of chintzy. No, not so. This, I mean, to the point of adding this glue down here around these parts to keep them from vibrating independently of the board. And it's on these coils too, and around to these things. And this is the reason that they make a really high quality product. It's very well manufactured. Now, the error code supposedly had something to do with the battery management system. By the way, if you do this to your box, you ruin the warranty. Don't do it. This thing tested good when I did the review on it, but it did have a problem. I've had so many of these now that it's almost inevitable that one would have a problem. Good grief, that thing's heavy. Okay, they're lithium cells, But boy, something's really heavy in there. I'd like to be able to test a single cell, but I don't see of any way of getting a single cell out of there without really breaking things, okay? What I want to do is measure the voltage across a cell. It's probably about 3.7 volts. And let's see if we can just kind of take a look at the battery management system and see if we see anything that is obviously blown out. And there should be some traces of smoke or something, or if it were a resistor or something, it could split in half. I'm not seeing anything that would cause a problem like that. What it does, there's a lot of intricate interties between the various parts of this. So what the bottom has in it is a 48-volt battery. That's what it's measured at. I'm not sure what it's supposed to be. The discharge monitored by the battery management system. Every time you buy a large lithium-ion battery like this one right here, this is a Golden Mate. It works extremely well. It says 12.8 volts at 20 amps. That's 12.8 volts when it is nearly fully discharged. I haven't used this in a while. Let us take this as for my QRP operating. Let's just go to voltage again. Okay, 13.34, which is about normal for a battery. So if you look at this and you can take 20 amps out of it, you're actually getting more than the 256 watt hours, which is a quarter of a kilowatt hour. By the way, they've just changed us to differential metering different times of the day. So how much a kilowatt hour is worth around here? On the order of 15 or 16 cents. We are an electrical utility out in the middle of the nowhere. The battery management system fault tells us that something went wrong with the board, okay? And we don't know what. We know at least that it failed safe, okay? That's good. So we've looked at all the different parts of this thing from the top, which has the cell phone charger right here. And if you pull this up, there's a little lamp right here that you can turn on. I prefer the brighter lamps because if you're out in the middle of nowhere with no power, you need some serious light. These are, interestingly, stranded wire. As is that, and that. That right there is not. Well, maybe it is. Okay, and then we've seen all the different parts and pieces. There's quite a bit of empty space in here, but I think one of the reasons for that is you got to get air over these things so they don't overheat, because then you can have a problem. This thing puts out a very considerable amount of AC power. It can do it for a short period of time, or just use it to charge your phone. Now, note that this is the master turn on here. This is for the light. This eco has to do with how it charges. It doesn't charge as fast if you put that on. The DC you have to turn on for these. You can take two of these and parallel them, and this is the plug that parallels them. You do them in parallel and you can get more power, and it can send power whichever way it needs to send. I'm trying to figure out if the neutral is connected to anything, because there is a ground lug up here, right there, but I don't know if it goes any further than that. And I don't think that these power outlets have anything on the neutral side. Okay, so interesting. That would be a good thing if you can put one of these together that you could use like for camping or something like that. Actually connect a ground to it, ground it to your vehicle or something. Have the ground here actually connected. The neutral is the longer side right here, and then this is the hot right there, okay? So it floats with respect to ground, which is not a real good thing, but it works. In here is the conversion to take whatever comes in here to what the battery management system needs to charge the battery, and then coming back out to do a nice sine wave AC inverter here. And when I review these, I test them to see that it's not only a sine wave inverter, but that you can have fairly large power factor that allows you to power tools, saws, drills, things like that from this. And it will power a microwave. There's a guy has a YouTube channel that is about paramotoring, and he was going to test one of these things, and he came up with the idea that he'd put the battery in his lap, and on top of that would be strapped a pizza oven. And when he took off, he put the frozen pizza into the, he's in the air doing this, put the frozen pizza in there, turned it on, and cooked it using the power from one of these. That's not what I'd recommend doing on a paramotor, but still very, very interesting. It's interesting how he found a way to combine the two. But it had enough power in it to run the pizza oven for, oh, I don't know, the 20 minutes it takes to cook a pizza. So it would have been run down by about 1/3 on that. So there you have it. We have dug into one of these things to see what's inside. And I don't know if anybody wants the parts, but they're here. A little hard to dispose of because this is obviously electronic parts in here, and a lot of them. And this are lithium-ion batteries, lithium iron phosphate batteries, okay, with a battery management system on board. So there you have it. I hope you enjoyed that. I did. Kind of fun taking it apart. And it won't go back together again because I cut some wires. If you'd like to help support this channel, you can. There's some links in the description below, or you can go to patreon.com/KE0OG. And there are other ways of doing it if you go to dcasler.com/support. So there you have it. Until we next meet, 73.